Okay, so welcome to this video. Today we'll be looking at sequences and series. So with me, I have a tutorial sheet that has a lot of questions that is going to help us understand all the concepts under sequences and what? Series. Okay, so in this tutorial sheet, okay, I've put questions that talk about the recurrence relations. Okay, so we'll talk about the recursive sequences, finding specific terms, finding constants. So you can see on question 1 there, that's a recursive sequence there. Okay, so we'll look at how to find it in a very easy way. Okay, from there, we'll talk about the summation notation, like this one here. Okay, this thing that looks like an H big E here. That's what the summation notation is. So how can we use it to evaluate infinite? I mean, not infinite, but finite sums. How can we use it to evaluate finite sums? Okay, from there, we will talk about arithmetic sequences. Okay, so you can see part C here, part D, those are just arithmetic sequences. And then from arithmetic sequences, we'll be able to find like the nth term in the formula, finding the A, which is the first term, the D, the common difference, and the like. And then from there, we'll move to the arithmetic series. Okay, so all these here are arithmetic sequences. And then I'll move to the arithmetic series. After the arithmetic series, we'll go to the geometric sequences, like question number 4 there. Okay, so the geometric series, geometric sequences. Yeah, and then the most interesting part will be how to apply now the sequences and the series to the medical field. So we'll look at the profit growth, okay, of a company using these sequences, the population growth, and yeah, so something like that. So you can see the questions here are very practical at the end. So we're going to see how we can nicely apply those concepts for the sequences, for the series, on how to solve all these questions in this tutorial sheet here. Okay, so we're going to solve all the questions here. So we can start solving from question number 1 there. So question 1, they're saying a sequence has numbers U1, U2, U3, and satisfies the condition that U n plus 1 is equals to 2 UN minus 6 for values of n that are greater than 1. Okay, so here they're saying given that U1 is equals to 2, find the value of U3. So how are we going to do that? Okay, so we're just going to use this one here. Okay, so to find U3, it means we have to calculate first of all U2, and then the U2 will help us calculate the U3. Okay, so I write this formula here, n plus 1 is equals to 2 UN minus what? 1. All right, so here I'm given that U1 is equals to 2. So I'm going to write 2 U1. So if here there's U1, this one here represents the value of n. So it means here it will be U1, which is the n there, okay, plus what? 1. So this one will be U2 is equals to 2U1 minus 6, which will just give me what? 2. The U1 will be told 2, then minus 6. So this will be 4 minus 6, which will give us minus 2. Okay, so it means the U1 we've been given is 2. The U2 we have found it's minus 2. So what about the minus? What about the let me bring it back. What about the U3 now? Okay, so U3, I'll do the same like what I did when finding U2. I'm going to say 2 U, because we have 2 there. Okay, I can put it 2 there, minus 6. This one will be equals to U, the n that you've put there, which is 2. It's the same that I'll put here, so it will be 2 plus 1. So this will be our U3 now, is equals to 2. U2 is minus 2 and then minus 6. So this will be minus 4 and then minus 6. So this will just be what? Minus 10. So it means U3 is actually minus 10. So we found what we wanted here, which is U3 minus 10. Okay, so the last one, they're saying find the sum, okay, as j goes from 1 to 4 of uj. So it means here we are just adding, okay, all the u's from 1 to 4. So we're adding u1 plus u2 plus u3 plus u4. So we have u1, u2, u3. So we are supposed to find U4. So using this formula, U4 will be equals to 2 U3, okay, minus 6. So 2 multiplied by minus 10 and then minus 6. This is just going to be minus 20 and then minus 6. So this will be minus 26. So it means U4 is minus 26. Okay, so now I can come back and calculate my sum. So this one will be equals to U1, 2 plus U2 minus 2 plus U3 minus 10 plus U4 minus 26. So this one will just be equals to what? 2 minus 2 minus 10 minus 26. Okay, so this one is going to give me minus 36. So that will be the sum for question 1A. Right, we continue with question 1B. So they're saying the sequence A1, A2, A3 is defined by the recurrence relation such that A1 is equals to K, and then AN plus 1 is equals to 2 AN minus 7 for all the values of n that are greater than or equal to what? 1. Okay, so the first question is write down an expression of A2 in terms of K. Okay, so I'm going to use this formula. So if I have AN plus 1 is equals to 2 AN minus what? 7. Right, so I want to find A2 in terms of K. So here I'm going to say A2, the 2, I can write it as 1 plus 1, right? So it means N there will be 1. So it means even here where there's AN, I'm going to put A1. So this will be A2 is equals to 2 A1 minus 7. Okay, but the A1, okay, the A1 has been given as equals to K. So this will be 2K minus what? 7. Okay, so we have A1 being equals to K. A2, we found it is 2K minus 7. Okay. All right. So the next thing is show that A3 is equals to this. Okay. So we are using this formula here. So A3 is the same as A2 plus 1, which is equals to 2 A2 minus 1. So in this case, the value of n here is 2. You've seen it, right? Okay. So A3 in short will be equals to 2, and then A2 is 2K minus 1. So this will be 4K minus what? 14. Is it minus 14? Okay. So it will be what now? We're finding A3. Okay. Yeah. So here, this whole thing here represents A2. And then I forgot another 7 here. So it will be 2 multiplied by this to be 4K. 2 multiplied by this, it will be minus 14, and then minus 7. So this will give me 4K minus 21. Yeah, so that is correct. So our A3 will just be 4K minus 21. Okay, so the last question is to find the summation, okay, from 1 to 4 of this AR. Okay, so they're saying the summation is if R starts from 1 to 4 of AR is just equals to what? 43. So this goes to 1 to 4 of AR simply means A1 plus A2 plus A3 plus A4. Okay, so they're saying this thing is equals to 43. And then the question is find the value of K. So we have A1, A2, A3. We need to find A4. Okay, so A4, we're going to use this formula. So it will be A4 is the same as A3 plus 1, which is equals to 2 A3 minus 7. So this will be 2 A3 is 4K minus 21 minus 7. Okay, so this is equals to 2 multiplied by 4K, which is 8K. And then 2 multiplied by minus 21, that will be minus 42, then minus 7. Okay, so this will just be 8K minus 49. So F4 will be equals to 8K minus 49. Okay, so we have A1, A2, A3. So we can replace them now into this equation. So A1 is K plus A2 is 2K minus 7 plus A3 is 4K minus 21. And then A4, it's 8K minus 49. So this is equals to 43. So like terms together, right? Okay, so we're going to say K plus 2K plus 4K plus 8K. So 8K plus 4K plus 12K plus 1, 13 plus this 15. So what we have here is 15K. Okay, we have 15K, and then we can also add the numbers. So minus 7 minus 21 minus 6, 20 minus 47. I mean, what are we going to get? Okay, what are we going to get there? So minus 7 and this one is going to give me minus 28, and then I have minus 49. So if I add this, I'm going to get 17, 1, 6. Okay, so this will be minus 77 is equals to 43. Okay, so like terms together, so we can erase this part. We're going to say 15K is equals to 43 plus 77. So 15K is equals to 43 plus 77. So it will give us 120. Okay, and then from there, we just divide both sides by 15. So K will be equals to 120 over 15. So this will just give me 8. Okay, so the value of K will be basically what? 8. All right, so we are done with question 1B. All right, we continue with C. So C, they're saying a sequence is given by the recurrence relation. X1 is equals to 1, and then xn plus 1 is equals to xn, and then in the brackets we have p plus xn. Okay, so where p is a non-zero constant. Okay, so the first question is find x2 in terms of p. Okay, so x1, it's 1. So I'm going to be using this formula here. So if I want to find x2, or I'll write x2 is equals to x1 plus 1, so that I make it in form of this formula. So it means on the other side to be x1 and then p plus x1. So you can see wherever there was n there, I've put 1, 1, 1. Okay, so this is our x2 because it's equal to x2. So x2 will just be equals to x1, which is 1, and then p plus 1. So this will just be what? P plus 1. So I'll write here x2, it's p plus 1. Okay, let's find the other question. They're saying show that x3 is equals to this. So x3 will be equals to x2 plus 1, so that I make it in this form. So now my n is 2. So this will be equals to x2 p plus x2. So this will just be what? X3 is equals to x2, it's p plus 1. And then I have p plus x2, which is p plus 1. So this will give me what? X3 is equals to p plus 1. And then here to 2p plus 1. Okay. So you can, we can expand this to find to show that our x3 is equals to that. Okay. So we're going to say x3 is equals to p multiplied by 2p, 2p squared, 2p multiplied by 1. I'm going to get plus p. Okay. P multiplied by this, p multiplied by this, we are done. This multiplied by this, we're going to get 2p. 1 multiplied by 1, we're going to get 1. So this one is 2p squared plus 3p plus 1, which is the same thing, which is here. So we've shown that x3 is equals to this. So x3 is equals to, I can write it in the way that they want. Okay, so that's that. And then 3, find the value of p, given that x3 is equals to 1. So if x3 is equals to 1, then our 1 is equals to 1 plus 3p plus 2p squared. So this will lead me to, if this one goes to the other side, to just become 1 minus 1, which is 0, is equals to 3p plus 2p squared. 0 is equals to, factorize p. So it will be p3 plus 2p. Okay, so that one is the same as p3 plus 2p is equals to 0. So p is equals to 0, and then 3 plus 2p is equals to 0. So it will mean p is equals to minus 3 over what? 2. Okay, so here, what we're going to do is we're going to discard this. This cannot be the answer here because they said p is non-zero constant. So it can be a 0. So we're going to pick this one as our p. Okay, so let's write our p somewhere. P is equals to minus 3 over what? 2. So from there, it means we can even find the actual value of x2 and x3. So x2 is just p plus 1. So minus plus 1. This will just be what? Minus it will be minus, is it 1 or minus 1? Okay, let's find it. So we have 1 minus 3 over 2. So this will be, okay, so this will be 2 minus 3, this will be minus half. Okay, so this will be minus half. Okay, so the value of x2 is minus half. Okay, what about x3? So x3 is equals to 1 plus 3 multiplied by p plus 2 multiplied by p squared. Okay, so this one, let's simplify it. Okay, so if we simplify it, we're going to get what? If we simplify it, we're going to get, okay, 1 minus 9 over 2 plus this one here. We first square this one, we're going to get 9 over 4. Then we multiply by 2, that will just be 9 over 2 as well. Okay, so this one will be 0. So it means x3 is just a 1. Okay, so what we have is x1 is equals to 1, x2 is equals to minus half, x3 is equals to 1. Okay, so I think we can see a pattern there. If the value here is odd, we get 1. If it's even, we'll be getting minus 1 over 2. So let's try to find x4. We see if it's giving us this. If it's giving us this, then that will be the pattern that will follow everywhere. Okay, so now let's find x4. So x4 will be equals to x3 plus 1. So I'm putting it in this form, which will be equals to x3 p plus x what? 3. So now we know x3. x3 is 1. P, we had found that it was what? Minus 3 over 2. And then plus x3, which is 1. So 1 here, I'm going to get minus 1 over 2. So it will give me minus 1 over what? 2. So x4 is minus 1 over 2. So what we see here is just a pattern, okay? If I have odd, I get 1. Odd, 1. Even, I get minus 1 over 2. So now, when it comes to writing down the value of this, it won't even be difficult. So x 2008, we just check, is this an even number or an odd number? So this one ends with 8. 2 can go into this number without leaving a remainder. So this is an even number. So whenever I have even number, the answer should be what? Minus 1 over 2. So we're going to say this is equals to 1 over 2. And we are done with question 1C. Right, so now we solve the last question on question 1. They're saying the sequence U1, U2, U3 is defined by the recurrence relation, this one. Okay, where U1 is equals to 2, where D is a constant, find or show that U5 is equals to 2. So I'm going to be using this same formula. So I'm going to say, since U1 has been given as 2, I can find my U2. So U2 is the same as U1 plus 1. We agree, right? Okay, so I'm writing it in this form. So it means N here is 1. So this will be equals to minus 1, the power 1, and then UN, but the N is 1. So that will be 2, because this will just be U1, right? And then plus D. So this one, it will give me minus 2 plus D. Okay, what about U3? U3 is the same as U2 plus 1. So this one now is my D. So it will be minus 1, the power 2, and then here, okay, it will be U2. So U2 is this number. So I'm going to say it minus 2 plus D, and then plus D. So this will be equals to what? So this will be a positive number. Okay. And then what? And then, okay. So U3. Oh, okay. So it will be positive number here. So this one will just be 1. And then if I multiply by this one, it will be minus 2 plus D plus D, which will just be minus 2 plus 2D. Okay, what about U4? U4 is the same as U3 plus 1. So now my N is 3. So this will be minus 1 to the power 3. And then here, I'm supposed to put U3 according to this equation, right? U3. But U3 is this. So I'll put minus 2 plus 2D, and then plus the D, which is outside here in this formula. So I'm using this formula. So here, minus 1 to the power odd number, it will be minus 1. Minus 1 multiplied by minus 2 to be 2, multiplied by minus D, 2, 2D, I mean, it will be minus 2D, and then plus D. This will just give me what? 2 minus D. Okay, so let's look at U5. U5 is the same as U4 plus 1. So the N is 4 now. So minus 1, the power 4. And then here, I'm going to put U4. But U4 is just 2 minus D. And then plus D. So this one is raised to an even power. So it will be a positive number. So positive 1 multiplied by 2 multiplied by minus D, and then plus D. This will just give me what? 2. Okay, so what we notice here is that, let me put U1 here, somewhere here. So U1 is equals to 2. So U1 was 2, and U5 is also 2. So this pattern, okay, since they said it's a recurrence relation, it means every after 4 terms, okay, it is going to repeat again. So U5 will be 2. It means U6 will just be this. U7 will be this. Okay, U8 will be this. And then U9 to be 2 again, to start repeating again. Okay, U10 will just be this. So this is a repeating, okay, or a recurrence relation. All right, so let's find, so we've shown here that this U5 is actually equals to 2, okay, here. And then deduce an expression for U10. So for U10, you don't even have to solve, okay? For U10, you don't even have to solve. We have observed that the terms like begin to repeat or to reoccur every after 4 steps. So this was my step 1, step 2, step 3, step 4. So after these 4 steps, it begins again at 2. Okay, so it means here U6 will be equals to what? If U5 is 2, which was the first one, it means U6 will be this one, which is minus 2 plus D. U7 will just be minus 2 plus D2. Okay, U8 will just be 2 minus D. And then U9, it will come back to 2. So it means U10 will just be equals to what? Go back to this one. So it will be minus 2 plus D. Okay, so if we're evaluating U10 in terms of D, that will just give us what? Minus 2 plus D. So we follow patterns here. Okay, so that is our U10. Okay, and then next we solve this one here. So they're saying given that U3 is equals to 3 U2, find the value of D. So U3 is equals, it's here, U3 is equals to here. So we can erase this other part. Okay, can erase this other part. So we've been told that U3, which is just minus 2 plus D2, is equals to 3, and then U2. So we're finding the value of D there. So let us expand. So we're going to have minus 2 plus 2D is equals to minus 6 plus 3D. Like terms together, we're going to have what? Minus 2 plus 6 is equals to 3D minus 2D. This will be 4 is equals to D. Okay, so we found the value of D, which is what? 4. And we are done with question 1. Okay, so thank you so much for watching this video. If you'd like to access full solutions to that paper, you can subscribe and access them at discretelearning.com. Again, if you're having challenges with your pre-med or your NS, okay, in any of these courses that I've listed here, biology, physics, chemistry, or math, okay, I would like to tell you about a platform that can be a solution to you. So that platform is discretelearning.com. Okay, so we have both the website and the mobile app, and these platforms have videos that can actually help you to better understand whatever you learn in class, and just show you a simple way in which to answer questions. Okay, so you can subscribe and get help in any of these courses: biology, physics, chemistry, or mathematics. Okay, both semester 1 and semester 2. So for whatever course you register for here, you're going to access tutorial sheets, full videos for tutorial sheets. You're going to access full videos for assignments. You're going to access full videos for past quizzes, for past tests. Okay, you're going to access full video solutions to past mid-semester exam papers and also final exam papers. Plus, okay, you have an opportunity to consult from us. So maybe if you are watching one of our videos and you do not understand, you can simply inbox us to consult on that particular question. Then we'll be able to help you. Okay. And a bonus is that we also have live classes. Okay. So these live classes, we explain concepts to you on a live class. So meaning you're able to we're able to interact with you and you're able to ask questions there and then so that you understand the concept. Okay, and our videos are basically tailored to your university syllabus. Okay, so we are teaching what you need to know in order for you to actually pass and get to understand these things very easy. So I'm just going to show you that we have solutions to, for example, I'll say all the math tutorial sheets. Okay, it's the same in chemistry, the same in physics, the same in biology. So when you come here, math tutorial sheets, tutorial sheet 1 is on algebra. So all these questions here were solved in a very simplified way that you can understand. Okay, so all these questions here in tutorial sheet 1 were solved, and the videos, they are available on the website. You can watch at your own time, at your own pace, even in your blankets. Okay, tutorial sheet 2 is on exponentials and logarithms. Again, we solved all these questions that you can see in this tutorial sheet 2, and the videos are waiting for you on the website. Okay, so once you watch these videos, you understand the concepts clearly, and you'll be able to answer questions in your assessments, like the quizzes, the tests, the mid-semester exam, even the final exam. Okay, there's also tutorial sheet 3 on functions. Again, we solved all these questions here. Okay, how to limit the domain, how to sketch the functions. We talk about the quadratic functions, and such things. Okay, all those questions have actually been solved. How to find the composite here. All these things we've solved. The videos are there, available for you at any particular time. Okay, so that was tutorial sheet 3. Tutorial sheet 4 is on sequences and series. Again, we've solved all the questions in this tutorial sheet. Okay, all the questions here have been solved. They're there. You can access them on the website. Tutorial sheet 5, differentiation and integration. This is a topic that most students find difficulties with or challenges. Okay, we've solved. Okay, I've shown how you can differentiate in a very easy way. Okay, so how many questions did this tutorial sheet have on differentiation? It had how many questions? 5 questions. We've solved all of them and you can access them on the website. Tutorial sheet 6 is on descriptive statistics. Again, we've done justice to this tutorial sheet. We've explained all the concepts clearly and you can access them on the what? On the website. Okay, so all these questions have been solved. Tutorial sheet 7, which will be the last tutorial sheet on probability for semester 1, okay, has also been solved. So all these questions that you can see here have actually been solved and they are available on the website. Okay, so in addition to the tutorial sheet, guys, you get to access the past papers, the quizzes, the tests, the mid-semester exams, the final exam papers. You get to access them, okay? And also the topic lessons so that you understand the topics fully. They are all available on our website. So we also have this assignment 1 here. It was solved. Okay, so assignment 1 had like 2 questions. There's this one on pharmacokinetics. We solved it. And then question 2 is on exponential decay and growth, okay, of bacteria. We've solved all these questions here and they are available on the what? On the website. So if you need help in any of those courses that are actually listed here, biology, math, physics, chemistry, you can subscribe at discretelearning.com and you're going to access them. So you can contact me on these 2 numbers here, okay, if you want. Again, let me just show you the website for those who have never seen it. So you just go to Chrome here and then type in discretelearning.com. So you can see the discretelearning.com there and then go search, take you to our website. So here, if you don't have an account, you need to create an account. So you just go to start learning now. Okay, then it will take you to the login page. So if you don't have an account, go here, create an account and then log in. But if you already have an account, just put your email, your password there and then log in. Okay, after you log in, these are the things that you're going to see. So you can see mathematics, chemistry, physics, biology, everything that you need to help you. So for example, I'll just use the math folder or the math course. If you open it, you go to your particular university. Okay, so if you're from Unilas semester, first semester, you go here. Unilas second semester, you go there. But if you're from any other university, you go in general mathematics. If you're from Apex, you use those. So I'll just use the semester 1s here. So if I click on the semester 1, you see that it's going to open and I'm going to have 4 folders: topic lessons, summarized, tutorial sheets, past quiz test, and exam paper. So if you go, for example, in the tutorial sheets there, okay, you're going to find videos for all the tutorial sheets. So you go to your intake. Okay, so the current intake now is 2026 January. I'll go in the 2026 January there. Okay, and you're going to see here the assignments are there and all the tutorial sheets are there, so you can learn and you can watch and learn from these videos at your own particular time. And if you have any question, you inbox us. Okay, so my number for those who want to register is 0779 96 40 10. So that is Tutor Solutions. Okay, but if you just want to self-register, you can check the registration video guide in the description below here. It's going to show you how you can create an account on the website, how you can register, how you can pay and access these, okay, automatically without even needing any of my team members. All right, so thank you so much for watching. This has been Tutor Solutions. Until next time, always there for you, and I wish you all the best in your exams.